Welcome to the tutorial. So this is a strength of materials or mechanics of materials. So here this topic is going to deal with basic definition of strength of materials or some basic terms that you're going to deal here, that is load, point load, distributed load, tensile load, compressive force, axial force and transverse force. So these are the terminology that here need to deal. Then after dealing this, next we'll go for uh, different topics and different uh, concepts in this tutorial. So now we start with a definition of strength of material. So here, so what is the strength of materials or mechanics of material? So mechanics of material say mechanics of materials that defines it is a it is a branch of mechanics, branch of mechanics that studies the that studies the internal effect of stresses, internal effect of stresses and strain, stresses and strain in a solid body, in a solid body. So here this is deals with only solid body, means apart from solid body, so no other body is going to consider. So which is subjected to an external loading. So any solid body which is subjected to, which is experienced with a external loading condition. So this is the definition that what we are going to deal with. Next, here some basic terms that we are going to define, that is a load. So what is a load? So why we consider load? Why? Because these are the simple terms that we are going to use in coming session. For that, you need to define the small terms. So here, the force acting on a body, the force acting on a body is termed as load. So force acting on a body is termed as load. This is the load definition. Next, point load. Point load. What is the meaning of point load? So this is defined as a concentrated load, a concentrated load is known as point load. It means a small area, a point area looks like a point, or a very small area where load is going to point, or load is going to act at a very small area, that is called a point load. Then distributed load. So how it's going to deal with load distribution over a length, load distribution over a length or over an area, load distribution over a length or over an area is known as known as distributed load. So this is done. Next, that deal with force. So here first we take a tensile force as it is given. Tensile force. So how it is defined? A load acting on a body, load acting on a body, that is solid body, which try to pull it apart, which try to pull it apart, means while two load is applied, if this is a free member, if two load is applied at the end of the member, so that load will try to take that material apart, means far away from each other. So how it apart? Such type of pulling force. So such type of pulling force. So this is a type of pulling force is known as tensile force. Tensile force. Next, compressive force. Compressive force. So how it is defined? But before defining this, let us have some pictorial representation that how it's going to looks like. Suppose this is a member, solid member, and that pulling force is applied at the end, and this is a section, say XX. What will happen? This force will try to take the material away from its original position. So means it will produce tension in the member or in the solid body. So this is A. Next we will take one more examples. If one end is fixed and another end is free, but at the free end force P is applied. So what will happen? This force will try to elongate the member. So that is nothing but a tensile force will act to elongate the member. So next is the compressive force. So how we will define the compressive force? Let us see compressive force. Compressive force. Force tending to push or compress. Force tending to push or compress a body. A body is known as compression or compressive force. So let us say, means what will happen in these situations, that length of the member will shorten or will reduce or will contract. Such force will tend to shorten. Such force will tend to shorten the length of member. The length of members. So then what will happen? So let us take a body, that a member, solid member, and while a load is compressive, load is applied on the members, so it will try to shorten or try to contract the, it will produce contraction in the body, and the length of body or length of solid object will reduce. So this is a force P applied from the both the ends. Next, axial force. Let's say axial force. So what is the axial force? A force acting on a body along the longitudinal axis. A force acting on a body along the longitudinal axis, are known as axial force, So let us say one more force, that is called transverse force. So what is the transverse force? Let's define, then we will make a picture to have very good clarity on this concept. So forces acting normal to the longitudinal axis. Forces acting normal to the longitudinal axis of a body is, or we can say here, are known as transverse or normal forces. So let us see with the help of diagrams how it's going to. So this is a member, solid member, and this is the longitudinal axis. A force is going to act along the longitudinal axis. So this force may be a compressive, may be a tensile. So let us see both the cases. One is tensile and second is compressive. So these forces, let us see P and P. These forces, and this is called longitudinal axis. Okay, and one more, this is the sections, and forces acting along this axis, this is called transverse axis. Okay, so these forces acting along this transverse axis, let us say P1 here, P1. So forces acting along the longitudinal axis called axial force, and forces acting along the transverse axis is called transverse force. So up to here, let us stop this tutorials. So thank you.